Hi guys, in this video we're going to talk about different separation techniques that we learned when we separated a bunch of mixtures the other day. So first off, I'm going to start by labeling this separation of mixtures, and we're going to be talking about the techniques to do that. So I'm going to put a little colon there. And I like to organize stuff in a chart, so that's what I've done. So I'm going to make a large chart here. Got lots of different separation techniques that we tried. So I'm going to have 4 columns and 6 rows when I'm all said and done here. And I like to make my rows and columns as even as I can. And there's 3 rows, and then I'll split this up into 3 rows. Remember, rows go side to side and columns go up and down. And 4 columns, just like that. And some of these I'm probably going to be writing a little smaller in, and that's okay. I'm going to label them across the top. First we're going to talk about what the technique is. Then we're going to write a description of how it works. And we're going to identify what it's based on, how it separates out those different parts, and situations where it doesn't work. Because some of those separation techniques only work if the conditions are just right. So we're going to start with, and we're going to kind of go in the same order that we did in the lab. First we have magnets, and I'm going to call this one magnetism. So, and what we did with this one was we used a magnet. Use magnet to pull out the parts that respond to a magnet. And pretty much everything that responds to a magnet has iron in it somewhere, so really we're pulling out something that has iron in it, but we're basing this on the property of magnetism that the particles have. This only works, though, if one of the parts has something that responds to a magnet in it. So if none of the parts respond to a magnet, then this one will not work at all. None of the parts respond to a magnet. Okay, so for example, sand and sugar, neither of those respond to a magnet. So a magnet is not going to be able to help you there. We'd have to use a different technique. Filtration is the next one that we did. Filtration is a funny word to say, filtration. And that basically means that you're going to be using a filter. So we're going to run the mixture through a filter, and there's lots of different filters out there, so you would have to pick the right filter for your materials. But what this is basing it on is that some of the particles are bigger than the other, so we're basing this on particle size. And this kind of technique won't work if the particles are the same size or if they're too small. Some of the particles are too small to be caught in the filter, and if all the particles are too small to be caught in the filter, then this definitely will not work. So our next one that we did was called decanting, which we kind of did when we did the filtration. Remember, filtration, we had sand and water, and we poured it into a filter, and the water came out, but the sand did not, although the water was a little cloudy. When you did that, some of the sand stayed in the beaker, and that property, or that technique, is called decanting, and that's when you pour the lighter material off the top. So we had some beads in a jar, and we were able to pour the water off and leave the beads behind in the container. That is called decanting. And that is separating it based on the density of the particles. So the heavier particles sink to the bottom and they stay there. Decanting doesn't work if the parts dissolve in the water. Parts dissolve. If they dissolve, it doesn't work. And if they have the same density, then it doesn't work either, because then we won't have one that sinks and one that floats. Or if they're close, they might mix too much. Decanting works best when you have a solid and a liquid, or a really heavy liquid. So the next one we did was with the salt and the water, and we didn't use a hot plate, but we definitely could have to boil it. But I'm also going to write evaporation here because that one would work just as well. And that is where you boil off a liquid, and that leaves a solid behind. And this fact that it leaves a solid behind is pretty important because the next one involves boiling also. And this is based on the fact that a solid can't boil. So as you're heating up the liquid, the liquid boils off and it leaves the solid behind. So we're basing it on phase, really. Excuse me. So if you can't use this if there's not a solid. If your solid dissolves in the liquid but it doesn't boil at the same temperature, then you can still use this because it will leave the solid behind. It will actually not boil away. That's what happens with salt water. We boil the water away and the salt stays behind even though the salt dissolves in the water. You could do the same thing with sugar and water also, and other materials would work well too. So the next one is called distillation. Distillation is like boiling. But this time we're boiling off a liquid and we're leaving behind another liquid. So this one is separating it off based on boiling points. So we watched a video where they had ethanol and water, and the ethanol boiled at a much lower temperature. So when the ethanol started to boil, what was coming off in the bubbles was just the ethanol, and the water was staying behind. So they collected the ethanol in one tube, and then after all the ethanol boiled away, the water started to boil, and they were able to collect the water. They left the water behind, and then they were able to collect the water somewhere else. So this doesn't work if the boiling points are close or if they are the same, because they'll both boil off at the same time. The last one that we saw was called chromatography, which is a nice long word that barely fits in the box. And this is where you use water moving on a paper. That is called capillary action, in case you're wondering, to push particles. This one is also based on particle size, but instead of filtering some of it out, this uses mostly small particles, and they spread out based on how fast they can go. The bigger particles can't go as fast, and the little particles can, so they get pushed a little bit farther. This doesn't work if the parts aren't water soluble. Okay, water is an important part of chromatography. That's the part that does the moving. Not all liquids do that, so we need to make sure that we have water. And when we say soluble, we're saying that it dissolves in water. That's what soluble means. So these are our separation techniques that you need to be aware of and be able to identify which one is going to work best for the mixture that you have. Thanks for watching.